So I asked you to multiply and graph this. So I have f of x equals 2 times x plus 2 squared times x minus 3. First thing I'm going to do is I'm going to write that twice. That's what the power of 2 means. You have 2 of these expressions, and then you also have x minus 3. That 2 right there, I'm just going to leave to the very end. So now I'm going to multiply x plus 2 times quantity x plus 2. Hopefully you used a box. So I'm going to write x plus 2, x plus 2. Class, go ahead and multiply. Here, here, and here. Let's go ahead and combine like terms. So what do you get? Now I'm going to multiply our answer in green with x minus 3. Now you'll recognize there's 3 terms. This is a trinomial. This is a quadratic trinomial. It's the highest power of 2, and there's 3 terms. So now I'm going to write x minus 3 over here. Let's go ahead and multiply. X times x squared. X times 4x. 4 times x. Negative 3 times x squared. Negative 3 times 4x. Negative 3 times 4. And now I can just combine like terms or add what's inside. So does x to the third have any like terms? Let's write x to the third. I'm putting equals because I'm saying that this expression, once I expand all of it, is here. Ah, I forgot something. I forgot that too. So 2 times all of this. Combine like terms. Plus x squared, so you're just adding the number in front. Negative 12 plus 4. Negative 8x. And then minus 12. And then we're going to go ahead and distribute that one. That was supposed to be a 2 right in front, so 2 times 2 times 2 times 2. And we're going to get a 2x to the third. So I'm just multiplying the number in front. Plus 2x squared minus 16x minus 24. Raise your hand if you got that. Now, is it possible you multiply them in a different order? Yes, it is. You could have done that. So you could have done something like x plus 2 times x minus 3, and you multiply that by x plus 2, and then you distribute the 2, that's fine. Or you could have distributed the 2, and you get 2x plus 4, and you multiply that by x plus 2, and then your answer multiply x minus 3, that's fine. Doesn't matter, your answer should be this though. Alright, let's go ahead and practice something else that we've done. Is now graphing this with multiplicity. So for each of these, I'm going to set each of these equal to 0. So let's rewrite it. F of x equals 2 times x plus 2. We'll keep it squared, then x minus 3. So I'm going to set each of these equal to 0. Now, although this is a power of 2, I'm just setting the parentheses equal to 0. And this one equal to 0. Raise your hand if you have that on your paper. Awesome. Let's solve it. Class, can 2 equal 0? Anytime? Never. No, 2 will never equal 0. We say that there is no solution. And you can just cross it off. The 2 does nothing to the graph. The only thing it does is it makes the numbers bigger, but it doesn't change what we're trying to find is the x-intercepts. If I subtract 2 from both sides, x is equal to negative 2. And if I add 3 to both sides, x is equal to 3, right? Because 3 minus 3 equals 0, and negative 2 plus 2 equals 0. Let's talk about the multiplicity. The multiplicity refers to what? The exponent, or the degree, or the power. You see that? That's why they call these power functions. So my multiplicity here is 2. And is 2 even or an odd? And what do you do with evens? Like that, guess. How about a multiplicity for x equals 3? Odd or even? And what do you do? Shoot. Let's color code this. Down to green. Down to pink. Draw a graph. So at negative 2, I'm going to put a dot. And x equals 3. Now, let's talk about its end behavior. The general function, if you look over here, the one that we expanded all that? Class, what type of function is this? Everyone say cubic function? Remember, cubic functions are odd degree functions, what we learned yesterday. Odd degree functions start down and up. I know that because the easiest one is linear. Does that make sense? So let's go ahead and put our arrows starting down. And also ending up. Now the great thing about having this here in standard form is that standard form can tell us the y-intercept. Because if I put in x equals 0, this goes away, this goes away, 0 times negative 16 equals 0, it goes away. Therefore I already know my y-intercept is going to be something like negative 24 down here. Let's go ahead and graph this. So as I approach negative 2, what's going to happen? It's going to kiss. It's going to bounce off the x-axis. I'm going to go down to negative 24. And then when I approach 3, what's going to happen? Okay. So that's what we learned last week. Now let's apply that to what we learned yesterday. Yesterday says that as, don't have an as here, as x approaches, in these first two you will always put positive infinity and this one negative infinity. Always. The reason why is because you're going in which direction here? Left to right. So this is your negative infinity, this is your positive infinity. And what happens to the graph? What's the last thing you touch there? The arrow is pointing where? Up. And up means what? Positive infinity. So the y values, f of x, goes to positive infinity. What does this mean? As x approaches, where does my graph go? Right to left. The last thing I touch is the arrow, which is pointing where? Which is what? negative infinity. And that's our end behavior. And that's how you multiply, graph it with multiplicity and end behavior.